Hey guys, we're looking at Leetcode 2845, count of interesting subarrays. This is a medium difficulty Leetcode problem, and the problem description tells us that we're given a zero-indexed integer array called nums and an integer modulo and an integer k. And the task is to find the count of subarrays that are interesting, and we're told that a subarray is interesting if the condition holds for each number. So we have an interesting subarray so that there are, but basically we have elements in a subarray where nums I modulo is equal to k, and the number of those elements which meet this condition is going to be equal to count, and that modulo should then be equal to k to have an interesting subarray. So a bit confusing, but we want to have count, which is going to be equal to the number of elements which meet this condition over here, and then if that's the case, and if the count mod k itself is equal to k, then we end up returning that we end up adding that to a result counter, and then we end up returning the number of subarrays that are interesting. And we're told that a subarray is a contiguous non-empty sequence of elements within a array. Okay, so let's look at some examples. So we have an example 324. The modulo is 2, and there are, in this example, the interesting subarrays are there's 3 of them, and it's basically 3, 2, and 4. And why is that? Well, there is only one index such that I is equal to the number modulo mod is equal to k, and that count should be equal to 1, and for each of these that is equal to true. And how can we solve this problem? Well, this kind of problem can be solved using a prefix sum and hash map, and the way we're going to solve this is let's take this example. We're going to basically map each element as to whether or not it passes this condition over here. So let's say we have 324, so we have 324, so 324, we map that to a binary array, so we have 1 0 0. So we have 1 0 0, and then we want to have a prefix sum. So we want to basically get 1 0 0. We want to map each number to a binary whether or not it passes that condition, and then we want to have a prefix sum. So we want to say how many times does this exist. So in each of these, the prefix sum is equal to 1, and then we want to go through a list when it iterates through our prefix sums. And if we get to a point where we've got like a remainder, but we want to find out what can we add to this remainder to make it equal to k, well, that's kind of like in a normal traditional prefix sum problem. We want to be solving for that. So I think it's a bit hard to come to to kind of figure out, but in our hash map that we're going to have, we're going to basically have the prefix sum of the number of elements that equals to k, right? So or that pass the condition. So let's say this is how it's going to look. So we're going to have pr minus p L minus 1, and what we want to say here is mod that modulo is that equal to k. Okay, so that's what we say there. So how can we isolate what we're going to be storing in our subarray? Oh, sorry, in our hash map. So this is going to be stored in our hash map, right? We're going to have a hash map which is going to have the sum of each time we've seen a remainder and the count. So a remainder and the count, how many times we've seen that remainder before. So we want to isolate for this so that if we what difference can we add to this so that we can get a remainder equal to k. So let's actually rearrange this. We're going to isolate PL minus 1. So we can say, P, there's going to be a couple of steps before this, but initially what's going to happen eventually is we're going to have PL minus 1 mod is going to be equal to PR minus K mod. So we want to find, actually PR minus K mod. So if we have this in our hash map, we want to check if we can add this difference, can we then get the remainder K? And if we can, then all the subarrays with that count are can be added to our result, because they're all going to be interesting subarrays. So I hope this kind of makes sense. It is a bit complicated to understand. I'm not sure if the way I've explained it makes sense either. But let's actually get to coding this up, and I hope it does make a little more sense as we get coding. So we're going to say binary map is going to be equal to the binary map that we discussed, and we're going to say, 1 if the number modulo, these name conventions are so confusing, equals K, else 0 for each number in nums. So now that we have a binary map, we have each we basically just have 1 0 1 0 0 1 like that, just binary array, whether or not each element passes the precondition. So what can we say next? Well, we want to have a prefix sum, right? We did say we want to have a prefix sum. So that prefix sum initially is going to be equal to 0, and then we want a result, and then we want to have a hash map, and we're just going to call it, count map. And initially we want to also handle the edge case of the subarray starting at index 1, so we'll have a 1 just to beat that edge case. And then we want to say for each value in binary map, so each value in our binary map, prefix sum plus equals that value. So now we have a prefix sum which contains the number, which will basically be equal to the number of times so far that we've seen a number that passes the precondition, which is numbers I modulo equals K. And then we want to have the difference, right? So what difference can we actually, let's first add to our hash map. Let's change that around. So we're going to say count map prefix sum, and then remember we want to modulo that as well. So we want to say modulo is going to be equal to, and then we want to just copy this. We want to increment this by 1 because we've seen this remainder before now. So we're going to say count map dot get, and then we're going to, if it doesn't exist, it's going to be a 0 and plus 1. So we're basically just going to go through our count map and increase each count by 1 that's equal to so how many times we've seen this remainder before, basically. So if we've seen this remainder before, we're going to have a hash map, which is basically going to have each remainder and how many times we've seen that before. And then we can have a key to find difference. So we're going to have a key, which is what we're going to look for in our hash map, so that if we have that difference is going to be equal to K. So we're going to say prefix sum, and remember, what did we say when we isolated the hash map value on one side? We got prefix sum minus K modulo. So that's the key that we want, and then we want to increment our result simply by looking for that. So count map dot get key or 0, and then after this we can simply return our result. So let's actually walk through the code just to make sure, do a bit of dry run, or at least just analyze the code itself. So, we are converting each number in our element, so in our elements list, to a 1 or a 0 if it passes this precondition. Then we're initializing some variables here, a prefix sum, a result, and a hash map. Okay. Fantastic. And then we are looping through that binary map, and we're saying we're adding a prefix sum. So what does this prefix sum actually have? Well, it has the number of times we've seen elements which pass this condition over here. So, we want to say if we have a remainder, if we found, a remainder, what can we, what difference can we add to that remainder, so that we can get that equal to k, and then we'll look for that by we rearranged our formula and we found out what we'd need to look for in our hash map. We'll increment the result and then just return result. So I hope that kind of makes sense. Let's submit the code now. And we see that we pass all 617 test cases for this problem. Quite a confusing problem and quite hard to explain, strangely enough. It took me quite a while to get my head around it, but I hope this, at least the solution made a little bit of sense to you guys. So in terms of time and space complexity, this is going to be equal to big O of n, of course, because it's linear in terms of time and because we're storing worst case scenario every value in our hash map. So with that being said, I hope you guys enjoyed this video and I'll catch you in the next one.